So let's take a look now at router 42 again. So I'm going to connect my rollover cable to router 42. If we do my show IP route again, we see that there are all these inter-area routes. One of the things I had mentioned during the slideshow is that our type 3 LSAs should not be propagated every time there is a network update on router 1. Well, if on router 1 I disconnect my PC from the router, so this is going to be disconnecting the PC from F00 of router 73, which means that we're going to have a topology change on that network. So let me disconnect this. That should generate a type 1 LSA in area 73, and then propagate the type 3 LSA into area 0. The type 3 LSA now is also going to propagate into area 42. So if I do my show IP route now, we should be missing a route, and here we are missing a route for network 10.73.1.0, which is the network that my PC is connected to. When I reconnect my PC, that will regenerate another type 1 LSA in area 73, which will be converted to a type 3 LSA when it hits that area border router, router 1, and then it'll propagate all the way into router 42 here. So if we do show IP route again, now we should see network 10.73.1.0 is added back into the routing table. Well, this kind of violates one of the rules we were talking about when I was explaining the benefits of multi-area OSPF. The big value here is that we get to control the propagation of LSAs. But right now, all we're doing is we're controlling the propagation of them. We're just changing the type, but not changing the behavior. So right now, our multi-area OSPF environment is not tuned at all, and realistically, it behaves identically to single area OSPF. Its identical behavior is in a functional sense, meaning that all routers in the OSPF network get LSAs for all routes. Well, right now, we're not doing ourselves any favor here for router 42, because it's getting all the updates. So let's fix that by doing a summary of area 73. I'm going to jump back to our slide here briefly so we can take a look at our drawing. So I want to do some summarized routes here. So what we're going to do is we're going to summarize the routes in area 73 to 10.73.00/22. And where we're going to configure that is on router 1. So let's go to router 1 and add our summarized route configuration. So I'm going to move my rollover cable over to router 1 now, and let's move into configuration mode. So in config mode, I'm going to go to router OSPF 10, and the command that I use here is going to be area 73 range. For area 73, I'm going to create a summarized address. So if I hit question mark here, it's saying what address are we going to summarize? So that's going to be 10.73.0.0. The mask we're going to put on there is a 22-bit mask, which is 255.255.252.0. And that should be the end of our command. We just hit enter here. And now, if I look at this routing table is going to be the same because it is directly connected to area 73. Now, I do have a route now on router 1 for my summarized route in OSPF, and it's giving me a null 0 here as my exit interface. Well, what the heck is null 0? Null 0 is an interface that goes to the bit bucket. It's a garbage can. So what's happening here is, remember when I talked about in the very first module of this course, how the router selects which route to use for a destination IP address of a packet. And it's going to use the route with the longest number of matching network bits. So let's say that we're sending a packet to 10.73.4.1. Well, if I look through my routing table, I don't have a route to 10.73.4.1. which means that it's going to match on my 10.73.00/22 network and therefore get sent to the bit bucket and get thrown away. And the advantage here is that I'm not forwarding messages into my OSPF systems that don't need to be there. If I go now and look at router 42, on router 42 now, if I do show IP route, what we should see is only one single route for all the networks in area 73. So now if I disconnect my 10.73.1.0 network connected to fast Ethernet 01 of router 73, if I disconnect that now, router 42 is never ever going to hear about an update from area 73 about that network going down. And the reason is that I have a route to everything in area 73. All I have to do is forward that into area 0, and area 0 will get it routed to the right spot. So now if I do show IP route again, my routing table has not changed after I've disconnected my interface on router 73. So here, using summarized routes in OSPF, I can effectively reduce the number of routing table entries in other areas, as well as reduce the number of the SPF calculations that need to be done to rebuild the routing table every time an LSA is received.